In this module, we introduce general nomenclature used in physical chemistry to describe chemical reactions. First, let's look at a generic chemical reaction. In this equation, the symbols R and P represent reactants and products respectively. Collectively, they are termed as reaction participants. The numbers R and P in front of these substances are called stoichiometric coefficients. Stoichiometric coefficients are positive integer numbers indicating the relative amounts of reactants and products involved in the reaction. However, there is a challenge. Just by looking at the stoichiometric coefficient, we can't determine whether it corresponds to a product or a reactant. We can overcome this inconvenience by introducing another, more general parameter, stoichiometric number. It is denoted by the small Greek letter nu, which is not the small Latin v. It closely resembles the stoichiometric coefficient, but with a crucial difference. For products, the stoichiometric number is just equal to the stoichiometric coefficient. For reactants, it is the negative of the stoichiometric coefficient. A simple way to remember this is by noting that in reactions, reactants are being consumed and products are being formed. By using stoichiometric numbers, we introduce one single set of parameters that describe how all involved substances participate in the reaction. Generally, the stoichiometric coefficients are selected to be the smallest whole numbers that balance the chemical equation. This method helps to avoid ambiguity when we talk about physical quantities related to a chemical reaction. When observing a chemical reaction, we often see various reactants being converted into products. Multiple reaction participants may be consumed or formed in the reaction mixture, but all the changes in their amounts are interconnected through the stoichiometry of the reaction. For each chemical reaction, no matter how many substances are involved, there is only one independent variable. This variable is termed the extent of reaction and is represented by the small Greek letter xi. Very generally, we can refer to each reaction participant in formulas using an index denoted here as I. The initial amounts present in the reaction mixture at the start of the reaction are labeled by N0I. The infinitesimal change of the extent of reaction, d xi, is equal to the infinitesimal change in the amount of any reaction participant, I, divided by its stoichiometric number, nu I. The extent of reaction xi itself equals the difference between the current amount of substance I and its initial amount Ni0 divided by its stoichiometric number nu I. Obviously, the extent of reaction equals to 0 refers to the initial composition of the reaction mixture. Importantly, due to the stoichiometry of the reaction, no matter which reaction participant is being considered, the result will always be the same. Assuming that the reaction goes in the forward direction, both the change in the amount of substance and the stoichiometric number are positive for products, resulting in a positive extent of reaction. For reactants, both the change in the amount of substance and the stoichiometric number are negative, also resulting in the same positive value of xi. Conversely, if the extent of reaction is known for a certain state of the reaction mixture, the amount of any reaction participant I, Ni, can be calculated as its initial amount, Ni0, plus the product of its stoichiometric number, nu I, and the extent of reaction Xi. Often, when we visualize a chemical reaction, we think of it as a one-way street, traveling from reactants to products. However, chemical reactions are dynamic processes. Not only their extent, but even their direction can be influenced by various factors, including the amount of reaction participants, both what we had named products and reactants. It is interesting and a bit counterintuitive that even when we write down a reaction equations with arrows pointing from reactants to products, this does not imply that the reaction will proceed in this direction in the physical world. A reaction might predominantly proceed in the forward direction under certain conditions, but if those conditions change, the reaction can reverse, moving more towards the reactants. The direction of the chemical change is indicated by the sign of Xi. A positive value indicates that the reaction has indeed advanced in the forward direction, leading to the formation of more product molecules from reactant molecules. On the other hand, if Xi is negative, it reveals that the reaction has favored the reverse direction, converting what we have labeled as products into what we thought were reactants.